Hello students, today we are going to start our next chapter, that is rational number. Before starting this chapter, let's discuss some important definition which we have already learned in your previous classes. The first one is natural numbers. All the positive numbers, integers like 1, 2, 3, 4 are natural numbers, or you can say that all the counting numbers which start from 1, 2, 3 are natural numbers. Whole numbers. All the natural numbers including 0 are whole numbers. All the negative and positive numbers including 0 are called integers. Or you can say that whole numbers including their negatives are known as integers. Now, natural number. Natural number are the numbers that can be expressed in the form of p by q, where p and q are the whole numbers, or you can say integers, but the condition is that q must not be equal to 0. It includes all the natural numbers, whole numbers, fractions and integers. Here in the diagram we can see the categorization of all the numbers. So natural numbers, the numbers 1 to 3 are natural numbers. When we add 0 to that, they become whole numbers. If we include the negatives of all the numbers, they become integers. And if we add fractions to them, then fractions and then negatives of the fraction, then these numbers are rational numbers. So it means that rational number includes integers, whole numbers and natural number. Or we can say that all natural numbers, whole numbers and integers are rational numbers. Now, what are equivalent rational numbers? If we want to convert some rational numbers into equivalent rational numbers, what we have to do? By multiplying and dividing the numbers and the numerator and the denominator of the rational number by the same integer, we obtain another rational number which is known as equivalent rational number. For example, if we have a rational number, say 1 upon 2, and we multiply this by 2 upon 2, does it make a difference? No. Why? Because 2 upon 2 is equal to 1, and when we multiply any number, multiply or divide any number by 1, it doesn't make any difference. So when we multiply 2 by 2 to 1 by 2, it doesn't change the value of 1 by 2, but yes, the number becomes 2 by 4. So 2 by 4 is the equivalent rational number to 1 by 2. Similarly, we can find infinite number of equivalent rational number to a given rational number. Let's discuss another example. Let's say, suppose we have given with 3 by 4 and we want to know another rational number. We can multiply this by any of the numbers of, let's say, 4 upon 4 is equal to 12 upon 16. So 12 upon 16 is the equivalent rational number to 3 by 4. Now let's check 2 by 3 is equivalent to 1 by 2, yes or no. Here you can see one more example, 4 by 8 divided by 2 by 2. Now when we divide any number by 1, that is 2 by 2, that is which is equivalent to 1, we will get 2 by 4. So 2 by 4 is the equivalent rational number to 4 by 8. Okay. Therefore, 1 by 2, 2 by 4, 4 by 8 all are equivalent to each other, or we can say they are equivalent rational numbers. Now, positive and negative rational numbers. Positive rational numbers are the numbers whose both the numerator and the denominator are positive. What should it be? All the numerator and the denominator should be positive. And the negative rational number. One more thing I would like to add here. If both the numerator and denominator are negative at the same time, then also a number is known as positive number. How we can say that? That is -1 upon -2 is also a positive rational number. Now, negative rational numbers are the numbers whose one of the numerator or denominator is negative. For example, -2 by 6, 36 by -3, all these are negative rational number. Remember one thing, that is the remark: 0 is neither a positive or nor a negative rational number. Rational numbers on the number line. Now, as we in earlier classes we have learned to represent the natural numbers, whole numbers and integers on a number line. So while doing so, we know that we place a 0 in between, and on the right side we place positive numbers, and on the left side we place negative numbers. Certain things to be remembered here, that the difference between each of the number should be same. That means all the numbers should be equidistant, either they are positive numbers or negative numbers. Okay, now let's try to place the rational numbers on this number line also. So we can say that rational numbers can also be represented on number line like integers. Okay, so like integers, positive rational numbers are placed on the right of 0 and the negative rational numbers are placed on the left of the 0. Here you can see the example of how to place the rational numbers on the number line. We can see that this is the 0, 1 and 2. Whenever we want to place any rational number, suppose here we want to represent 5 upon 3. Now, as 3 is the denominator, we will mark 3 small equidistance between 0 to 1, that is 1, 2 and 3. Place 1 over here, again 1, 2, 3 and 2 over there. Now how much? 5. So we will count 1, 2, 3, 4 and 5. So here will be 5 by 3. This is how we represent any rational number on a number line. Now, what is the standard form of a rational number? A rational number is in the standard form if its denominator is positive integer and there is no common factor between numerator and denominator other than 1. Okay, so two things we must consider, that the denominator should be positive and there should not be any common factor between numerator and denominator other than 1. If any given rational number is not in the standard form, then what we can do? We can reduce them into a standard form. How can we do that? By dividing or multiplying its numerator and denominator by the HCF. Okay, and ignoring the sign of negative. Let's just understand with the help of example. Find the standard form of 12 upon 18. Now 12 upon 18 is given to you. We know that HCF of 12 and 18 is 6. That is, the common multiple of 12 and 18 is 6. So we will divide them by 6 upon 6. While dividing, 12 divided by 6 gives us 2 and 18 divided by 6 gives us 3. So 2 upon 3 will be the standard form, or you can say simplest form of the rational number 12 upon 18. Comparison of rational numbers. In certain stage, we need to compare two rational number, which one is the greater and which one is the smaller. So to compare the two positive rational numbers, we need to make their denominators same. Then we can easily compare them. Okay, what we have to do to compare? We make their denominator same. So it would be easy for us to compare them. For example, compare 4 by 5 and 3 by 8. Now, what we are doing? We are comparing two numbers, that is 4 by 5 and 3 by 8. So to make their denominators same, what we have to do? We have to find the LCM of 4 and 18, that is 40. Okay, to make this 5 as 40, what we have to do? We have to multiply this number by 8 by 8, and to make this denominator as 40, we have to multiply this number by 5 by 5. Okay, so multiplying 4 by 5 by 8 by 8, we get 32 upon 40, and multiplying 5 by 5 to 3 upon 8, we get 15 upon 40. Now we can easily compare these. Now as denominators are same, we can easily see that 32 is greater than 15. So 32 upon 40 would be greater than 15 upon 40. Now 32 upon 40 means 4 by 5. So 4 by 5, and 15 upon 40 is 3 by 8. So 3 by 8. So 4 by 5 is greater than 3 by 8. We know that the number, when denominator in a rational number, when denominators are same, the number with greater numerator is greater. But if numerators are same, then the number with smaller denominator is greater. Always remember this thing. Now, how to compare the negative rational numbers? When we want to compare negative rational numbers, we compare them ignoring their negative signs and then reverse the order. Or you can say, what we can say, that while comparing negative rational number, so if the number having negative sign and greater number with negative sign is a smaller number, and we know that minus 3 is smaller than minus 2. Okay, so here we can see that the value of a number decreases due to negative sign. Okay, so the same with the rational numbers. Now how to compare the negative numbers. Here we have to compare 2 upon 5, minus 2 upon 5 and minus 3 upon 7. The process would be same. What we have to do? We have to take the LCM of the denominators and make their denominators same by multiplying the HCF. Okay, here 35 is the LCM of 5 and 7. So multiply 2 by 5, ignoring the sign. First what we are doing? We are just ignoring the sign. So 2 upon 5 multiplied by 7 upon 7 gives us 14 upon 35. Similarly, 3 upon 7 multiplied by 5 upon 5 gives us 15 upon 35. Now compare them without sign. So here we will notice that 15 upon 35 would be greater than 14 upon 35. It means 15 upon 33 by 7 is greater than 2 by 5. But when we put a negative sign, we will reverse the sign. If it's 3 upon 7 and minus 2 upon 5, what will we do? We reverse the sign and it would be like this. So 2 by 5 minus 2 by 5 is greater than minus 3 by 7. If we have to compare one negative and one positive rational number, then it is clear that the positive rational number will be always greater, as the positive rational number is on the right side of 0 and the negative rational numbers are on the left side of 0. For example, if you want to compare 2 by 5 and minus 2 by 5, it is very clear that the negative number is always smaller than the positive one. So, it's simply comparing like this. Now, next is find the rational numbers between two rational numbers. To find the rational numbers between two rational numbers, we have to make their denominators same. Then we can find the rational numbers. So students, there are infinite number of rational numbers between any two rational numbers. Okay. Now let's discuss this with the help of example. Find the rational number between 3 by 5 and 3 by 7. Now to find the rational number between these two numbers, first we will equate their denominators. So 5 by 7 and 3 by 7. So we will multiply both the numbers, 3 by 5 by 7 by 7 and 3 by 7 by 5 by 5. So we will get 21 upon 35 and here 15 upon 35, right? So this we will get 21 upon 35 and 15 upon 35. Now we have to find the rational number between them. So from 15 upon 35 to 21 upon 35, it's quite easy. 16 upon 35, 17 upon 35, 18 upon 35, 19 upon 35 and 20 upon 35. So these are the 5 rational numbers between these two rational numbers. And not only these, there are infinite rational numbers between them. Okay. So for that, if we want to find more than 5 rational numbers between them, what we have to do? We have to find the equivalent fraction of both the numbers. What we will do? We will find their equivalent fraction, or we can say we can multiply this by 3 by 3 or 4 by 4 or anything. Just find the equivalent fractions of both and we get more number of rational number between them. Like this, okay. If you want to there is 2 by 2. So if we multiply them 2 by 2, both of them 42 upon 70 and 30 upon 70. Now there would be, we can easily find more number of rational numbers between them. Now one thing we have to remember, that there are n number, that means infinite numbers of rational numbers between any two rational numbers. Operations on rational numbers. As we have already discussed the operations on natural number, whole number, similarly how the different operations, addition, subtraction, multiplication and division work on rational numbers. So let's start with the addition. Addition of two rational numbers with the same denominator. If the denominators of the rational numbers are same, it is quite easy to add them. Suppose, let's take this example, 1 upon 5 and 2 upon 5. As the denominator is same, so we can simply take 5 as LCM. So 1 plus 2, that means 3 upon 5 would be the answer. Okay, so it is quite easy when their denominators are same. If we have to add two rational numbers whose denominators are same, then it is easy. Okay, but if we have to add the rational numbers which with the different denominators. Here is another example which have same denominator. So 3 upon 11 and 7 upon 11, it would be 3 upon 7 upon 11. Okay, so 10 upon 11. When we have to add the rational numbers with different denominator, what we have to do, we have to add the rational numbers with different denominators. Then we have to take LCM of the denominator to find the equivalent rational numbers with the LCM as the denominator and then add them. Let's understand with the help of example. Suppose we have to add these two numbers, 2 by 5 and 3 by 7. So first we will make an equivalent fraction. Okay, so 2 by 5, here LCM of 5 and 7, 5 upon 7 is 35. Now to convert 5 into 35, what we have to do, we have to multiply this by 7. So we will multiply the digit by 7 by 7, it would be 14 upon 35. Now this 7 should be converted into 35, so we will multiply this by 5 upon 5, so 15 upon 35. Now it's easy to add them. 14 upon 35 plus 15 upon 35, that is 29 upon 35. Additive inverse. So what are additive inverse? Additive inverse is a number which when added to the number gives us result as an identity. Okay, so identity is 0. Okay, so the additive inverse of a rational number is also the same as integers. If a is the number, then minus a would be the additive inverse of a. This shows that additive inverse of 3 by 7 is minus 3 by 7. Suppose we have to find the additive inverse of a negative number. Suppose minus 2 by 5. If we want to know the additive inverse of minus 2 by 5, it would be minus of 2 by 5. So it would be 2 by 5. Okay. Subtraction. The next property is subtraction. If we have to subtract two rational numbers, then we have to add the additive inverse of the rational number. Then it begins being subtracted to the other rational number. A minus b is equal to a plus minus b. Let's subtract 4 upon 21 from 8 upon 21. Now here you can see that the denominators are same. So what we have to do? We have to subtract this from this. So 8 upon 25 should be subtract this upon 4 upon 21. This is how we write down. So we simply when denominators are same, we simply subtract the numerators and write down the answer, that is 24 upon 21. Okay, here you can see. But if the denominators are not same, then what we have to do, we have to take LCM as we done in addition, and then we have to solve them. Now multiplication. Multiplication of a rational number with a positive integer. When we multiply a rational number with positive number, we simply multiply the integer with the numerator. Okay, when we multiply any positive integer, we simply multiply the numerator with that. That is here 3 by 7 multiplied by 5, it results 3 into 5 upon 7. Okay, that is 15 upon 7. When we multiply with the negative integer, it's same. When the integer is negative, we place a negative sign over there. Multiply of a rational number with another rational numbers. Okay, when we have to multiply two rational numbers. So the product of two rational numbers is equal to product of numerators divided by product of denominators. What we have to do? We simply multiply both the numerators and both the denominators. For example, 3 upon 7 into 5 upon 11. So what will we do? We multiply 3 to 5 and 7 to 11. The answer is 15 upon 77. Now the fourth is division. First, the reciprocal. What does the reciprocal mean? Reciprocal of a multiplier is the given rational number which gives the product 1. Okay, what is reciprocal? It's a rational number which when multiplied to the given rational numbers results 1. So 1 upon 2 to 1 upon 2, its reciprocal will be 2 upon 1. So here you can simply say that a upon b is the rational number, then b upon will be the reciprocal of that particular number. Product of reciprocal. When we multiply the reciprocal of the rational numbers with the rational number, then the product is always 1. The product is always 1. Division of a rational number with another rational number. When we are dividing two rational numbers, so what we have to do? We have to multiply the reciprocal of the rational number with the another rational number. Here you can see 3 upon 7 is divided by 4 upon 11. So what we have to do? This would be converted to 3 upon 7 multiplied by reciprocal of 4 upon 11. What we have to do? We just multiply. Here the sign is changed. Divide changes to multiply, and this changes to this, the reciprocal, and the answer will be 33 upon 28. So students, today we have discussed all the theory part of the rational numbers. Hope you all understand that. In our next class, we will discuss the exercise of this chapter. Thank you.